Death Valley in the United States. It's one of the hottest and most hostile places on Earth. Here, our team of 5 scientists face their ultimate test, a series of challenges all about space exploration. Our 5 scientists are Kathy Sykes, an irrepressible physicist who thrives in the face of adversity. Iain Stewart's our first rough science geologist and an eternal optimist. McCallie is an intrepid botanist from Missouri with a never-say-die attitude. Mike Bullivant's our creative chemist who makes magic with everyday items. Jonathan Hare is a physicist, inventor, artist, a true Renaissance man. And then there's me, Kate Humble, here to lend a hand. Together, we are Rough Science. Mission Control is an abandoned silver mine on the edge of Death Valley. Here, the scientists have basic kit and simple tools. Ingenuity, they supply themselves. Now, as you all know, it can be pretty chilly out in space, but if you're standing on the bright side of the moon, temperatures can be high enough to boil the blood in your body, not unlike hanging around here, which is one of the hottest places on Earth. So, your challenge this week, Mike, Kathy and Iain, is to make some sort of coolant for a rough science spacesuit. OK?
Spacesuit.
A spacesuit.
Coolant.
Yeah. And then, Ellen and Jonathan, you've got to come up with some sort of system to circulate that coolant around the suit. OK? You're all looking at me as you're absolutely horrified.
We are.
You've got 3 days, as usual. At the end of the 3 days, we're going to hop over the mountains to Death Valley, where, you'll be pleased to know, temperatures regularly top 50 degrees, which is over 120 in old money. So it's hot. And we need to stay cool. You've got all the stuff around here, as usual, that you can use, anything that you can find lying around, and you have the magic trunk. Wow. Even by rough science standards, this is a tough challenge. A nicely chilled spacesuit in just 3 days. What are the sort of component parts? What have you all got to come up with that's going to make this work?
We need something to make something like a liquid, something like water maybe, really, really cold to begin with. So some kind of refrigeration device.
Yeah.
And then you've got to get that away from the fridge.
Yeah.
Pump it round the body.
That's so simple.
Yeah, I don't know what you're all complaining about. You know, come on, you can knock that off in an afternoon, you guys. Fortunately, Kathy has got a plan. Something to do with a spray can full of water. Keep going.
How does that feel, Kate?
Fantastic. It's so cool.
Well, that is the whole principle that we're going to use, or try to use, for our cooling system. We've got water on your skin. It evaporates off, so it goes from water to a gas. And to change state, it needs heat energy. So your arm cools down as it provides the heat energy for this to change state.
So this is exactly the principle of sweating.
Exactly.
When you sweat, the sweat that your skin produces then evaporates off and cools you down.
That's it. And we're going to try to use that mechanism to cool down a fridge.
The principle is simple. Evaporation leads to cooling. How she's going to use it to make a fridge isn't quite clear yet. But assuming the fridge works, Ellen and Jonathan have to find a way of using it to cool Ellen's spacesuit.
We're going to fill up a system like this, full of water. So it's a closed system. We're going to have the water flow into the fridge, cool off, and then come back around, cool me off.
Brilliant.
And then go back in to be cooled off again by the fridge, so it's constantly pumping around.
And the key to it is being able to pump it, of course.
Absolutely.
Because otherwise it's just going to be there cold and not...
And they're hot.
Yeah. So I think what we can do is, hopefully, this will all be full of water, and then if we have a motion like that with a little gizmo, a machine, it will basically push the water around and pump it round.
It sounds easy, but their pump will have to circulate cold water from the fridge to the spacesuit and back in a never-ending cycle. Kathy's getting to work on her fridge. She can't use electricity because it has to work in Death Valley, and it's got to be portable too. So what's her secret?
This is the beginning of the fridge here, OK? It may not...
This cooking pot?
may not look like a fridge. It's going to be a fridge.
OK.
And there's going to be water inside here.
Yeah.
And what I want to do is force the water to evaporate. The only way I can do that is to put the water under kind of vacuum conditions.
Right.
So I need to reduce the pressure, and as I take the pressure lower and lower and lower, the water will start to evaporate.
OK, so basically, that evaporation process, exactly the way that sweat evaporates off your skin, cools you down...
That's it.
...is cooling the pot like fridge.
Yeah.
But there is one problem. The fridge won't work unless she can keep the water evaporating. And apparently, that isn't going to be as easy as it sounds.
We're dealing with a vacuum. We need an airtight system.
Yeah.
But the problem we've got is removing the water vapour as it's formed.
Because that's going to heat everything up again.
Yeah, and it will stop any more water from evaporating. It will ruin the vacuum.
Right.
Once there's water
So
in the
if
air.
we can remove it, then we're quids in.
If they can find a way of removing the water vapour, then Kathy's fridge should work. And Mike's had an idea, inspired by the washing powder he found in the trunk.
There's a wonder chemical in detergents that will mop up the water.
So it'll act like a sponge?
Yeah.
What is it?
Well, it's a chemical called zeolite.
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 OK, so how much? Just about a spoonful?
Yeah, well, let's try.
So there's more to washing powder than meets the eye. If Mike can extract zeolite from it, this will absorb the water vapour and save Kathy's fridge.
Shake it up again. And gradually all of the soluble stuff will just be removed with the water and all we'll be left with is the zeolite.
Zeolite?
Yeah.
Oh, that's going to be a long process.
It's going to be tedious. We're going to be up all night, mate.
Iain's not convinced that there's enough zeolite in the washing powder. And he's getting a bit bored shaking up plastic bottles.
I've had an idea, and because zeolite isn't just synthetic, it's not just artificial. You get it in nature.
Right.
And you particularly get it in volcanic rocks.
Yeah.
So I reckon that these volcanic landscapes that we've got around us will have those volcanic rocks with zeolite in them. So I want to go off and try and hunt down some natural zeolite.
So now Iain and Mike both think they can find zeolite and save Kathy's fridge. Let's hope one of them really can. That leaves Kathy free to see whether she can start creating a vacuum.
Balloons? What are they doing in there? Look at the sizes.
Yeah.
If we create a vacuum, they ought to get bigger because the pressure inside the balloon stays the same.
Right.
The pressure outside gets lower, so they expand.
They expand. OK.
That's what they should do. So just squeeze them up there. Yeah. And now we have a very, very basic pump. You may have seen one of these before.
Yes, to seal up wine bottles, to sort of create a vacuum in wine bottles to keep wine fresh.
That's it. Well, Kate, we're going to try to create a bit of a vacuum in here.
Do you think we really can?
Get pulling.
Oh, my word, I knew there'd be a downside. OK. If the balloons expand, it means the pressure is dropping. If it drops enough, they might even burst.
Kate, look,
Is it working?
look.
Wait, everybody come and do this, come and do this! Look, come and look. Before I expire!
Look, check that pressure gauge. Can you see?
So the vacuum pump works. Now what Kathy needs most of all is that zeolite to soak up the water vapour. Iain and I are off in search of this magic mineral. Zeolite, is this some kind of byproduct of lava or
What
how
it
does
is,
it form?
yeah, what it is, it's the volcanic material, either lava flows or ash,
Yeah.
and the interaction with water just turns the whole thing into a clay-like, soft, powdery thing.
Right.
And that's what I'm hoping we get, because if we get that, that's meters thick.
Iain's highly trained geological eye has spotted the remains of a lava flow.
Ooh, it looks a bit dirty.
How's it looking?
It's good, it's good.
Yeah?
This is all lava flow here, this is all volcanic. And we've got a whitish layer just sitting underneath, which has all been chemically altered. It's very porous, and it's white. I think this could be zeolite.
Iain could be about to steal Mike's thunder. Has he really found zeolite? There's a rather unusual test to find out.
Right, I've got it
OK, so
finely powdered.
Yeah.
Hopefully zeolite. So if this is zeolite, what's going to happen is, as we heat it, and what we'll see is the rock appearing to fizz and bubble.
Should I give it a little shake?
Yeah, go for it. Yes! Excellent, that's exactly what we want. Boiling rocks, excellent stuff. We've found ourselves a bit of zeolite.
Something out of kind of, you know, a wizard's cavern.
This is the kind of alchemy Mike would be proud of.
That's
Fizzing away.
amazing.
Mike, eat your heart out.
Boiling rocks.
Yeah.
Day 2, and Kathy's enlisted Jonathan's help to make a new improved pump for her fridge. If it works, this should give her the pressure reduction she needs to evaporate water and cool the fridge.
We're going to pump from here, and we've got, instead of the pathetic little wine pump,
Yeah.
we've got the new mega big pump.
Which only takes 3 people
Just
to
3
operate.
people. And all I've done here is just taken the same mechanism out of here and put
Yeah.
it into here.
Right.
But we've got a much bigger drawer now, so we've got the potential to have a much, much bigger vacuum, I hope.
Okay.
Okay, guys, pull.
I can feel it's pumping.
Okay, and just keep on pulling, because there's quite a bit of air to evacuate.
It's lowering.
What's happened? Look, it's around here. Look. The thing's buckled.
Well, the pump worked, but all it did was collapse the pot. It obviously needs serious strengthening to withstand the low pressures Kathy's after. Ellen and Jonathan are ready to test out their system for pumping cool water around the spacesuit.
So we connected the whole system up. This is what Ellen's going to wear.
Yeah.
This is going to be in the fridge.
Yeah.
It's all got water in it. So all we need to do is test it out. So we've got a bit of dye in there, so hopefully it should move down. Actually, we haven't got an air bubble, have we?
No, but you can see the dye. It's moving down quite quickly.
Oh. Yeah.
Yeah, it's working. Is
Oh,
that working?
yeah. Beautiful.
Fantastic. Where's that going to be? Where's the pump going to be? Is it going to be on you?
No, I think we should mount it on top of the box.
It could be on Ellen, but actually, she doesn't want to have to worry about this thing. No, we can just mount it on the fridge.
After his success with zeolite, Iain has stepped in to try and save Kathy's fridge from collapsing.
So, we've been making a really nice... See that?
That's brilliant.
It's just braced, really, with wood.
Yeah.
All the way down.
So you've kind of built it a skeleton, effectively, to keep it out.
Absolutely. And I think, because we're going to want really, quite a good vacuum in there.
Yeah.
So it's going to need to be really rigid.
Yeah.
I think it's there, though.
No, not bad.
Nearly.
More good work from the fridge repairman. What we desperately need now is the spacesuit. And Jonathan and Ellen are starting to put it together. Are you making one knot?
I'm making a zigzag, and this is going to go on Ellen. This is going to be full with the cool water.
In
cool it
theory,
down.
cool water.
Yeah.
Right.
Okay.
Look at that.
Can we bend this bit down?
Yeah, I don't want to hurt your shoulder, but... Whoops. There we go.
Brilliant. I might have to play around with it a bit.
Gorgeous. You've got your own radiator only working the other way around.
Quite nice, Jonathan.
Yeah, I think that works. Gorgeous. Now all you've got to do is attach it to the suit, presumably.
Red's not my colour.
Maybe red isn't Ellen's colour, but the idea is to keep cool, not look cool. Not that there's any danger of that, but the spacesuit is coming along nicely. OK, the sun is fast approaching the horizon. It's end of day 2. This is the test.
This is the test. It's feeling quite scary.
The glue is dry, the fridge has been reinforced, the zeolite is in place, and there's a probe to measure the temperature inside the fridge. So will the water evaporate enough to cool the fridge down?
Water temperature is 24.9 degrees C.
It is.
We want the pressure to go down
Yep.
and the temperature to go down.
OK, start pumping.
Okay.
Yep.
Nothing happening yet. The pressure is dropping.
the pressure is
dropping.
Hey,
OK, we're at about
-10.
There is no temperature change in the water.
Come on.
You know what? We are going to be sweating buckets in the desert while Ellen is
Cooling.
slightly chilled.
Mikey B.
We're nearly at 30%. The pump is certainly reducing the pressure, but it's not yet enough to lower the temperature inside the fridge.
We're creeping up to -50, guys. Keep going.
We've raised that.
It's getting harder and harder to reduce the pressure any further, and everyone is getting tired.
When we started, it was 24.9. It is now stable at 24.8.
Oh, we've done it.
It's not going to keep you very cool, though, Ellen, is it?
Despite everyone's hard work, Kathy's fridge has failed.
What an end today, too.
We need some ideas, and fast. Without a fridge, Ellen's moonwalk in Death Valley will be very hot indeed. Day 3 brings a glimmer of hope. Mike thinks he's found a new way to cool Ellen's spacesuit. This time, his inspiration is a bag of fertilizer.
Well, since our cooling system doesn't appear to be working, what I've come up with is this jolly plan. It's a great wheeze, a chemical solution to the problem. We were given up this fertilizer. Now, I know that when you mix equal quantities of ammonium sulfate with table salt and boil it for half an hour with stirring, what you get is ammonium chloride. Now, when you dissolve ammonium chloride in water, this process takes place that sucks all the heat out of the water, or most of the heat.
Mike's fertilizer recipe could yet save the day. But if his clever chemistry does produce cold water, he's going to need something to keep it cold in the heat of the desert. This time, it's Kathy to the rescue. She's not giving up on her fridge.
It isn't really much of a fridge, but it is quite a good cool box.
OK.
OK.
Yeah.
Because we've got to nice low pressures. They're not low enough to get loads of evaporation and loads of cooling, but they are low enough that we should be able to keep something that starts off cold nice and cold.
And we still do all the pumping and the vacuum and everything?
We're going to have to do the vacuum again because we've
Yeah.
got to keep that nice low pressure.
So, Kathy's fridge has turned into a rough science cool box to keep Mike's chilled water from heating up. But first, we need Mike's chemistry to produce that cold water.
So you have crystals?
We have crystals of ammonium chloride, impure, but crystals nevertheless.
And do you think these are going to help with our cooling effect?
Let's try it, eh?
Yeah. So you literally just add these to water and it makes the water cooler?
Yeah, if we just add a teaspoon.
OK. Oh, it's dropping. It's dropping. It's already down to 24.6. 23.2, 22, 20... Sticking around about 20, so you've lost about 6 degrees.
Just about 6 degrees. Which is not bad for a teaspoon.
Yeah, but it creeps up again, doesn't it?
Yeah, we can't. But in the vacuum, if we use this to supplement our cooling device,
Yeah.
in a vacuum it'll be insulated, there won't be any heat conduction out.
Very true.
So it'll maintain that temperature a little longer.
It may not be ice-cold water, but it should at least produce some cooling in Ellen's spacesuit. Now they're all working flat out to ensure the heat of the desert doesn't quickly warm the water up again before Ellen can finish her moonwalk. The vacuum in Kathy's cool box will help, but they're also going to put it inside a wooden box for added insulation. Silver foil should reflect the heat of the sun.
Oh, beautiful. Look at that.
And of course, the whole system needs wheels, otherwise Ellen won't be walking anywhere. And here it is, a portable, insulated cooling system. Will it keep Ellen cool on her moonwalk in the searing heat of Death Valley? And if you're wondering what's on the car roof, it's the water for the cooling system. Kathy's wrapped the container in a damp cloth. It's her last-ditch attempt to use evaporation to cool the water. Ellen has abandoned the red suit, not because of the colour, it was just too hot. She's opted for the white one instead. It's thinner and the white material should reflect the heat. The copper pipes will circulate water from the portable cooling system around her body. If that water isn't cold, then she'll very quickly overheat. But at least she's got a bit of help from the weather. It's surprisingly overcast.
OK, rough scientists, this is the big moment. We are in the depths of Death Valley. It is
39.8 degrees. That's about 104 degrees out here. Ellen, I have to say you're looking absolutely stunning.
What a cool suit.
Now, your system is all charged up, isn't it? Ready to go?
Right.
A probe will keep tabs on the temperature inside Ellen's spacesuit. Time to add Mike's crystals to Kathy's roof-cooled water. Immediately it's dropping. 21, 20. Mike's chemistry has worked. The water is much cooler than the air temperature. Now Kathy's cool box has to keep it cool whilst Ellen does her moonwalk. So it's time to start reducing the pressure.
Yes, it's starting. OK. Keep going, guys. We have a vacuum starting. We're nearly at 20% already. Really fast reactions, really fast.
We're using a thermal imaging camera to see if it can pick up any sign that Ellen is being cooled down by the spacesuit. Red is hot, blue is cold.
OK, guys, I think that's probably enough pumping. Well done. Thank you.
Right, Jonathan, take over.
OK.
The pump should start moving cool water around Ellen's spacesuit.
Oh!
It's dropping!
Look at that!
It seems to be working. Ellen's suit has cooled down dramatically. The effect is very clear on the thermal imaging camera.
Wow, that was really coming!
Now the challenge is to see if Ellen can keep her cool as she sets off across the desert. If the pump fails or the cold water isn't insulated well enough, then the suit will quickly overheat.
Give us a temperature update, Ellen! Give us a temperature update!
21.8. It's freezing against my skin.
It's a knockout. Look at that!
The wheels are looking a bit dodgy, but so far there's no sign of the temperature going up. It's one small step for Ellen, one giant leap for rough science.
Oh, the Union Jack's coming out! OK, Ellen, we want a temperature reading at your furthest point.
23.6 degrees. And the flag is in the
Done!
I think we can pronounce this a success, can't we? Yeah! Well, that's all for this week, but join us next time for more rough science. Well done. Absolutely.